Awesome, awesome. All right. Well, 9:04, I guess we can get started. Yeah, today we have Gurgly from Sphere Course gonna talk about some monitoring stuff that he's built. Gurgly, take it away.
All right, thank you. Let me share this window and you can get started. So I prepared some slides that I plan to go through, but feel free to stop me at any time. And also, if the connection seems to be sometimes going away, just let me know using my mobile broadband for this connection from a hotel room. So it's not the best, but hopefully it will work. So before we dive into the resource tracker stuff, I wanted to share a little bit about SpareCores because I think it's important to build some credibility for this open source project. So this is vendor independent, cloud vendor independent, and dedicated to be open source. Started as an EU grant last year and being also accepted to a few other programs like NVIDIA Inception. And based on that, we received some cloud credits so that we can run benchmarks and hardware inspection tools on cloud servers. And that was the first big thing for SpareCores, spinning up all the available cloud servers at the hyperscalers, also at Hetzner, UpCloud, and get to know all the cloud servers and make a data set out of that. I will show one related slide around that. And yeah, I've been trying to push this project at a few offline events, at some online communities as well. We had some good rides on Reddit as well. Even Jeff Barr said some nice things about us. But yeah, let's switch to the actual topic. So SpareCore started as an inventory of cloud servers and cloud resources like traffic prices, storage prices, regions, availability zones at many different vendors, build a standardized data set out of it. And we run quite a lot of benchmarks on servers and made that available in a standardized way, like LLM inference speed, memory bandwidth, and web serving databases, stuff like that. If you're interested, check that out. And we also do some related open source projects. Most recently, been focusing on resource usage so that you can tie together the cloud server data with your usage patterns so that you can find the right instance sizes for your future model training to save costs or to make those model trainings more performant and run faster. So that's about the project. And on LinkedIn, I've learned that some folks might join today who are not familiar with Metaflow. So I prepared some backup slides to do like a 2 or 3 minute intro to Metaflow, but honestly, I'm not sure if they are here. And listen, if you see only familiar faces, then we can totally skip these slides and switch to resource tracking. Can you confirm if you see any new attendees, or everyone is familiar with Metaflow?
I see Sebastian. I'm not familiar with Sebastian. Do you want to speak up?
Yeah, well, I'm somewhat new to Metaflow, but I know the base. I don't think we need, for my part, we don't need a Metaflow intro. But yeah.
Okay. Perfect. Thanks for the feedback. I will post my slides, and if anyone interested will be able to find this. All I wanted to show is that you can build some really nice workflows and schedule different steps on different remote executors like Kubernetes, AWS Batch, and so on. You can specify your resources. And here I just wanted to ask that, okay, here we are training model A and model B in parallel, and then in the eval step, we are finding or selecting the best model. But how do you actually know that your fit A step indeed requires 32 cores and 64 gigs of memory? And if the other step needs only one GPU, maybe it could scale to multiple GPUs as well. So I've felt that pain in the past when I was working with data science teams, that it's not trivial to find these numbers. In many cases, we are just over provisioning, or things are failing because running out of memory. And I also ran a LinkedIn poll a couple of weeks ago asking how much time data scientists, machine learning engineers spend configuring cloud infrastructure per week. And around 50% of the folks said none, because someone else is taking care of that. Around 10% of the folks said that several hours, and the rest, like 40%, was below 1 hour, which is quite a lot. So I was thinking about how to create tools so that you do not just make up these numbers, but you collect empirical data, like how much resources actually we need for the feed A step and for the feed B. And you have some open source automation so that you can forget about the resources decorator and just auto-tune that based on the collected resource usage data. So here comes the resource tracker to the rescue. That was the plan, which is like a standalone Python package with the minimal dependencies. Actually, that's zero dependency if you are using Linux with a modern kernel, because we can use the proc file system to collect memory usage, CPU usage, and a few other things. If NVIDIA SMI is installed, then we can also track the NVIDIA GPUs usage and so on. On Windows and Mac, we do need psutil to track CPU memory, storage, and a few other things. All the recent Python versions should be supported, so you should be able to run it anywhere, like no need to install anything, and if Python's available, it should run. It can monitor the resources at the system level, so what the server or your laptop is using, and it can also focus on a single process, including optionally older child processes. What's being tracked now is CPU time spent in user space and in kernel, as well memory usage, GPU utilization. We can do that for processes as well. So if you have like multiple GPUs in a server, multiple processes using some of those GPUs, we can separate the usage percentage for those, well, up to 4 GPUs. And also we can look at the VRAM usage. Traffic in, traffic out, as in bytes per second, the actual storage being used on the server, and disk read and write as well, and a few other things. So try to collect as much data as possible so that later we can make use of that. It was intended to be easy to use without like any setup or code updates. It's running in the background, so it's not blocking your main thread or your actual application, because it's starting processes in the background. On Linux, it's just forking. Other systems, it's spawning a new process for the resource tracking. And I also wanted to work on framework extensions so that you do not need to start the resource tracker manually, but it can be automated, like in Metaflow. So to use this thing, you can install from PyPy, and the minimal example you can see here. Once you import your resource tracker class, you create an instance, you do something, and then the data is automatically collected in the background processes, and you can just report. That's the most basic thing to do. And you get an HTML page like this one. And let me open that up in a new tab and show the details. So in this HTML page, all the collected data is presented in a few different ways. First of all, there's some information about the system that was executing your process. So you can see that this is a Linux server with 4 vCPUs. It got a single GPU, some memory, and so on. We also do not only hardware inspection to get these basic characteristics of the server, but doing some cloud discovery as well. AWS, Azure, GCP, Hetzner, UpCloud are supported right now, and we will figure out which cloud provider is being currently used, which region, the instance type, and in this case, so that I can feature some of the SphereCore's data. This clicks out, and you can find like a ton of information about the actual server, a lot of open that. So hopefully you might find that useful at some point, and also the related cost. Then regarding the data collected, we have some aggregated statistics here, like the average CPU usage, the maximum or peak CPU usage, same for memory, GPU, VRAM, disk space, and so on. And all these are used to come up with recommendations. If you would like to rerun your Python or R script, then you could use this resources decorator in Metaflow, or if you're doing the standalone version of the Python resource tracker, then you can run it on a server with the provided number of CPUs, memory amount, GPUs, and so on. You can also find some recommendations on the actual server, which is the cheapest for the listed specs. Like here, you can find a Google machine, which is much cheaper than the one that we run on this. So you can make some nice cost savings. Then there are some time series data. So the CPU usage, memory usage, and all the other collected metrics are presented both at the system level, which is the blue line, and at the process level, which is the green line, so that you can see the amount of memory was taken by your processes, and so on. So this is the base use of the resource tracker. If there's any questions or issues, just let me know. Otherwise, I will continue and show how you can access this data in a programmatic way if you are not really into looking at these charts manually.
I have a couple questions. So where does it store the data? You were showing that at some SphereCore's website.
Yeah. So this one is I just put a static HTML on the sparecores.com homepage, but when you are running this on your machine, it's just generating the HTML file on your machine, and you can open up there. So it's not like a software as a service solution. Everything is running on your machine. So this is just an example report.
Got it. Got it. So the idea that we run the flow, and then we track all these utilization, and there's a recommendation as to how to set the resources for the next run.
Yes. And actually, I prepared like a demo so that we can use the sandbox to run a flow. You can see the interactive charts attached, and then you can either manually update the resources decorator for the next run, or we can also automate that, which is not in the main branch yet, but should be soon available. I'm in the automation part.
Mm-hmm. So this assumes the workload is fairly stable?
Yes, that is correct. It's using the averages of the historical data that you provide for the standalone version. If you're using the Metaflow integration, then it's looking at the last 5 successful runs, and it uses the peak memory usage of all those. So to answer your question, it relies on instability in the resources being used. Although if there's a pattern that you might need to do a longer loop back, that can be totally done by looking up, let's say, the last 1 weeks of history. For peak memory usage, that's great, but if the resource usage is totally random and really depends on your input, then probably it's not the best approach. I have some slides where I describe how the resource recommender is being run. I mean, the super basic algorithm, and super happy to hear any feedback and recommendations on how to improve that.
So one problem we have is with out of memory issues. And it's oftentimes difficult to let's say you pick some memory value for your step, and then you ran out. Then you don't really know like how much it's supposed to take. So we would just allocate a whole bunch and then check that it succeeded, and then like tune it down. Like, do you have any thoughts on how we would improve that?
Yeah, we had that issue quite a lot as well. And the automated approach was when we found an OOM event, then we retried the job with higher memory, which was basically the max memory used by sampling and adding 20% extra. And then we just kept trying until it succeeded. Of course, if you started the job with 2 gigs of memory and it requires 400 gigs, then it will take some time to get there. And in some rare cases, it required some manual intervention so that we bumped it quite a lot. But usually that super basic approach was enough to overcome this problem.
Mm-hmm.
So just retrying with a bit more RAM in an automated way so that human work is saved.
Mm-hmm.
Did Metaflow do that? Like retry and change the resources?
So Metaflow on its own does not. With the resource tracker integration, it could do that with some hacks. And I would like to share those hacks that I've included in the resource tracker and get feedback from the group, because I'm pretty sure there are much better ways to do so, even without ugly hacks.
Yes, please. Interested in seeing that. All right. I think I'm good for now.
Cool. Okay.
Wait, I want to ask a question. Sorry.
Please, go for it.
So, like, because you show the CPU utilization and the RAM utilization, and maybe GPU as well, but like, you don't necessarily know what's going on in your code when those things happen. So I was wondering, like, would it make sense to add like a logging feature that allows you to put a watermark on the x-axis that says like, here we're in the 4th iteration of the for loop or something like that?
Yeah, that's a good point. Currently, we only have timestamps for the resource usage. What I'm planning to do is to add some logging so that we also know which line of your code is being executed, and then you can just join those data sets together. Like you were saying, then we could annotate this plot or come up with other ways of visualization so that you know which part of the code is being executed, which would be also, I think, very useful so that we could recommend if you might want to split your step into multiple one, because in the same step, maybe you need a lot of memory at the beginning, then you need GPUs and so on. So it would make sense to separate those apart. So yeah, that's a really good feedback. And I do have related plans, but we are not there yet.
That kind of reminds me of Memray, or one of those profilers you put on as a decorator, and it gives you like the flame graph of every single function you call. Like that would be pretty sick. I mean, I don't. It might be overkill, but that'd be pretty cool. Anyway, that's it for me.
Yeah, it'd also be really cool to see like a breakdown of what objects are contributing to the memory usage.
Yes.
That's a great idea. I'm not currently sure how to do that, but we'll think about it. If you have any recommendations top of your head? Super happy to hear that. If not, we'll
Yeah, I remember I
investigate.
used some tool. I don't remember what it was. Because I had to debug an issue where some user was saying loading artifacts was consuming a lot of memory, and they expected the artifacts to be a certain size. And then I loaded it and checked, and it was using that much memory. And you could see the actual like types that were being used.
Got it.
Related to the retry hacks with different resources, I wanted to ask Nissan, like some of the other, like Flight, for example, does let you do dynamic resource setting. Like you could do a SQL query and you could have like one CPU for every 100 rows in a result set or something like that. Do you think Metaflow will ever add that? Like that level of dynamism?
With custom hacks, you can already do that, I think, in the, well,
Well, the problem, I won't say problem, but the limitation right now is that a lot of these orchestrators, you have to harden out the DAG at deploy time.
Right.
I mean, if we were to dynamically launch the nodes, then yes, we could specify the resources on the fly.
Which would probably only work for Argo at best.
Yeah, maybe a small subset of other ones.
Oh, nice. Cool. This is off topic, but yeah, it's something we've been thinking about a lot.
you can override the numbers in the resources decorator in the step init method, right?
At runtime?
I think so, because that's the step init part is not running on the executor. Am I correct?
I think that might be implementation dependent. Like on batch, it's too late. You're already like on the. Well, depending on how you structure it, like say you're in step functions, then in the DAG it'd be like launch this machine with this many resources.
I'm in
Yeah,
the step decorator step init method. But okay, I will check on that.
Yeah, we could double check the details.
cool.
All right. If you want to look at the data that's being collected and not only look at the HTML that you can generate from Python or look at the cards attached to the step, here, looking at the system metrics of the tracker object. This is like a custom data frame implementation because I wanted no dependencies. So it's just a basic class which can do like stats and joining things and so on, but this is the data that we collect. So by default it's sampling once a second, but you can configure that as you wish, and you can go like every 100 milliseconds or whatever. Time spent in user space, system time, computed CPU usage, some memory related numbers collected, regarding disk IO, space used, free storage, traffic in and out, and also GPU related metrics like percentage of GPU cores being utilized, VRAM, and the number of GPUs. Same stuff for the process related metrics. So we have timestamp, the process ID, number of children processes, and pretty much the same columns, except for disk IO and traffic, because I was just not able to track that in a reliable way. So those are only available at the system level. You can also combine all these to a data frame where both the system and process level data is available, and just highlighting some related features, like it has some flags so that you get some nice column names, which is useful for doing data visualization in the card. So here you can see the system metrics and then the process metrics. You can also call the stats method, which is providing averages and peak values for a bunch of different things, which is being used for the resource recommendations that I will highlight in a bit. When calling the stats, by default, it's using some stat specifications, as you can see here in the doc, but of course you can override and get whatever statistics you are looking for based on the data that was collected. The recommender returns a dictionary, like number of CPUs, memory amount, GPUs, and VRAM. When it comes to Metaflow, the first three is supported. As far as I know, in the resources decorator, you cannot configure the VRAM amount. I'm not sure if that might be possible to do in the future. I think it could be super useful. Not sure if there are any plans.
What is the difference between, like, yeah, what does this VRAM thing do?
Oh yeah, sorry. So like the GPU memory,
Oh, okay.
like video RAM, like because in many cases you might need, not just a single GPU, but a GPU with 60 gigabyte of memory. So you need like a powerful one.
Yeah, the way we're currently handling that, at least internally at Netflix, we have T-shirt sizes for the GPUs.
Oh,
Yeah, so you say like I need a small, medium, large GPU.
but you cannot. How do you handle that within the resources decorator?
We have a mapping that like we know that these particular machines have these GPUs.
Okay. I would love to learn more about that if there's any publicly available talks about it.
Yeah, we can follow up with you on that.
Okay, cool. Regarding the algo that's being used for these recommendations, this is super simple. And like you have already pointed out, it really relies on the assumption that resource usage is similar when you are rerunning the step. Because we are looking at simple things like targeting the average CPU usage of the processes, which is basically just checking if your step can scale to multiple CPU cores or not. And if it can, then we can scale it up. Peak memory usage, if GPU was used and if it was used, let's say if the application or step can scale to multiple GPUs, and again, the GPU memory is pretty much the same. One extra information here that you can pass the historical stats list as well, so that if you're using the standalone version and you're collecting the stats somewhere, you can pass it, and in this way you have like a look back window. If there's a pattern in your steps that early in the mornings it's requiring more RAM or whatever, then this can handle that scenario. The recommend server algo is super simple. It's basically looking for the cheapest server with the minimum specification based on CPU, memory, and then GPU, and that's it. So there's some related documentations. If you're interested, please check that out. I have some plans on how to extend this, and one of those is streaming the resource usage data to a central location, like an object storage, so that you have everything in a central place. And even when using the standalone version of the resource tracker, can collect all that data for you. Because in Metaflow, you have artifacts, and you can get the data from the artifacts, but in the standalone version, you would need to take care of that. So some related automation would be great. Of course, tweaking the recommender algo would be great. Honestly, I'm not really into the idea of trying to estimate how much memory we need based on the input, because I think that's kind of an impossible task. Like what I think Eric, it was you who mentioned that in flight you could do that. We need some memory for every million records returned from the database or something like that. But there might be so many different factors contributing to the actual memory usage that I would not even dare to go in that direction. But if anyone I'm sure there are much smarter folks out there. So really looking forward to any recommendations and improving that. Regarding the server picker, I think we can do some super useful and valuable additions with very simple logic. Like in many scenarios, you're tied to a single cloud vendor, maybe to a single region. So adding some filters for that would be already useful. Instead of looking for the cheapest one, what we have did at a previous company, we looked at the cost efficiency metrics instead of just cost. So we took into account the performance of the server and checked like if a job or step can scale to multiple CPUs in a perfect way, then we started larger machines which could perform much faster. And even though we paid like 4 times more, but we did 10 times more. So it made sense to allocate to larger boxes and so on. So the spare cores data that we have collected on those thousands of servers could be useful. Anyway, the actual topic for today is the framework integration. So what I've created is a Metaflow extension, which provides the track resources decorator, which is starting this resource tracker in the background in an automated way. So it would do the hardware spec lookup, cloud discovery. It would start the resource tracker in the background, looking at the mentioned metrics, and generate the HTML reports as a card. So if we have time, I'm very happy to show that in the sandbox. Do we have time for that?
Yeah, you got
Okay.
25 minutes left.
All right, then let me install the resource tracker first.
So it's the same package that is the Metaflow extension and the standalone.
Yes, that's right. So it's the standalone resource tracker, and it also includes the Metaflow extension. So let's switch to the scaling out to the cloud step. And here I have to import the track resources decorator from Metaflow as it was installed as extension. I will uncomment this line and request 10 gigs of memory as suggested by the comment, and adding the track resources decorator here. And what I would like to also do is let's sleep here for 2 seconds before we request that memory. And let's sleep for 2 seconds. Right after that, see that we collect some data, and well, let's see what happens. So just clicked running the flow, and hopefully things will show up pretty soon on the UI. Okay.
I've never seen that UI. Is that the from Outer Bounds?
Yeah, this is the Metaflow UI where you can see all the steps. So let's see, we are waiting for the memory hog step where we have used the track resources decorator. So these guys should soon finish. Okay, so this is the memory hog 6. And hopefully the related card will load in a bit. I'm not sure if it's my internet connection or things went wrong, but there you go. Okay, so here's the card that was generated. Maybe I open this up in a new page. So we knew a little bit about the server being used in the sandbox, but let's focus on the actual job. It seems that we have not really used much CPU. There's no historical data because this was the first job. If we rerun this workflow again, of course, it would pick up the historical records. Regarding memory, it seems that we only used 500 megabytes. Ah, okay. So it seems that we have not tracked a lot of memory usage, and I think that's because here we quickly computed the length of this string, but we have not really reserved that memory for enough long so that we can do a sampling. So let's do something like this. So we will keep the string in memory, and this way we will actually pick up the memory usage. So sorry for this extra cycle, but at least we have identified one issue with resource tracking. If things are happening within the sampling window, of course, there's a chance that we might not capture that. By default, the track resources is using a 1 second interval. You can override that and go with, let's say, 100 millisecond or something like that. And then you have better chances to capture the highest memory usage. All right.
I saw Eric had a question, something about enabling by default. Like, how much overhead is there?
I could just say it, like, because this is cool, and tracking is cool, and I assume there's some amount of overhead for tracking this resource utilization. So, like, would you recommend that people just turn this on for all their flows and all their steps on their team?
Yeah, I would definitely do that, and we have done that at previous roles. Not the exact implementation that we have here, but something similar, and it helped a lot. Of course, there is some overhead. For example, for the GPU utilization, we are using the NVIDIA SMI CLI tool. So that's starting that process like every second or whatever interval you specify. If you do not have a GPU, then that step is skipped, and then it's super lightweight, because on Linux it's just looking up files in the proc file system. So that's very cheap. But for GPU, well, it takes like 50 milliseconds to start that binary. So there's some overhead. But I would totally enable this for everything. In the meantime, I'm trying to reload this UI, and hopefully now we have a card where we do see some memory usage. Okay, there you go. I'm opening in a new tab so that we can see all the details. So now it seems that, okay, we indeed use more than 1 gigabyte of memory, if I'm reading this number correctly. And scrolling down, looking at the memory usage, you can see that the server overall used like 12 gigs of memory, and at some point that jumped to like 13. If you are focusing on the green line, which is the process-related data, we started at 200 megabytes, and then after the 2 seconds, it jumped above 1 gigabyte, and at the end, I think it jumped back to 0. But what I wanted to point out, that just looking at the stats and also like the recommended resources here, it seems that you are totally okay with 2 gigs of memory. There's no need to, use the recommended 10 gigs here, right? So that's hopefully a useful feedback for the data scientist working on this flow or actual step. And also what I wanted to point out that, well, you can see that now we have historical records also loaded, and both for CPU and memory. All right, that's about the demo part. I wanted to share some implementation details and get your feedback, and hopefully there are much better ways to do so. So the historical data is by default going back and looking up the artifacts from the 5 most recent successful runs, so just disregarding the failed ones. Although the resource usage data is also kept for the failed runs, but when it comes to recommending, we are just not taking that into account. When you are using the track resources decorator, card decorator is injected for this step in the step init, which is probably not the best way to do, but this is how I managed to overcome the issue that you do not need to, provide the track resources and then also like show the card for the collected data. So to get everything done with a single decorator, there's this hack in the step init method, dynamically adding a new card if it's not present. Hopefully there are nicer ways to do this. Very happy to hear any related recommendations. If not, then we can move on. I also needed some hacks so that we can generate cards for failed steps, because cards are only generated when a step was run successfully. And I got some requests, which are, I think, very fair, that I would like to see the resource utilization of a step that actually failed, which could be useful to identify if it was running out of memory, if it was scaling to multiple CPUs, and so on. So what I've done is in the task finished method of the step decorator, like manually rendering the related card that was injected in the step init method. If there are more elegant ways to do so, I'm super happy to do that as well. And one limitation is that this is rendering the card at the end of the step, either after a successful or a failed execution, but it's not real time. And for long running steps, it would be really cool to do real-time updates so that you can check how resources are behaving while your step is still running. So I have some related plans to overcome that, either with the streaming approach, so that data is collected in a central location like an S3 or any other object store, or thinking about how we can do real-time card updates with the collected data. But I'm not sure if artifacts are stored at the end of the step, so really not sure how to pass data around. So if you have any feedback or related ideas, let me know.
Yeah, not off the top of my head right now. I don't work too much with cards.
I can think of a few options for cards, but I feel like it's no better than the approach we already have. Because like you only want the card if you have the resource decorator, right? The resource usage. Yeah. There's like a default card decorator you can use, but then that will be added to all the steps, so still not good.
Mm-hmm. Got it. Thank you. Anyway, if anything comes to your mind, please let me know. Super happy to
but for the real-time thing,
yeah,
I think I've heard of it like long time ago. Maybe we can check with something about it, because like that might be something they can support, or maybe already support. I'm trying to look up the doc and see if it's possible.
So you can do real-time updates in the card, but my problem is that the card is generated from an artifact, which is stored when the step finished. So creating real-time cards is possible, but I'm not sure how to pass the data for the real-time updates, because the artifact is not there yet. I mean, the resource usage artifact.
But
anyway,
does it have to come from an artifact?
So in Metaflow, currently it's structured that the resource tracker is running in a background process. And at the end of the step, we are reading all that data from the background process and storing that as an artifact, which is then picked up by the card render thing. It doesn't necessarily needs to be that way, but I'm not sure what other ways do you have to pass data around, especially that your step might be running on a remote executor and things like that. So that's why I fall back to using artifacts, because those will be valuable no matter what executor you're using, right?
Mm-hmm.
But if the card render is running on the same executor, there might be some approaches to share data between the step decorators. I just don't have enough experience with Metaflow internals to come up with a better approach.
Yeah, I feel like there's a way we can make this work, but we need to put a little bit more thought into it.
Okay. Super happy to follow up on that. All right. I know we are about time, so I will just wrap up. I do have some plans in the future to improve this. One that I promised to do like 2 months ago. I was just busy with other things, but doing the automated tuning of resources, I played around with this. POC is ready. I just need to clean that up. And I had some success with hot patching the resources values on the fly, and it seemed to work with the Kubernetes operator. I have not checked AWS patch, so I'm not sure. Like Nissan, you mentioned that it's too late to do the updates at runtime, so we'll see. In Kubernetes, it seemed to work. So that's the first thing I would like to do. The second one is collecting data.
So just on the Kubernetes one, is that going through an orchestrator or just launching on Kubernetes?
Just launching on Kubernetes.
Okay.
Yeah. So this is the biggest thing I would like to add. Second, I would like to work on this central location of resource usage data, and I find that a powerful idea that all your steps and flows, resource usage data is collected the central place. You can also, group things into projects and teams and so on, so that you have like a 360 view of all the data science, ML related things, and use that for some FinOps approaches. And yeah, I would love to see some updates regarding the resource decorator, so that you can also specify the minimum amount of video RAM or GPU memory. We have discussed that briefly. You mentioned that t-shirt sizes are being used at Netflix. I'm very open to any related recommendation, but just would like to see how we can improve that. Not sure if you have received any related requests from others in the past, or that's just
possible. We have. I think Sabin would know.
okay. All right, we can also follow up with him. And this is, I think, something Eric recommended, that if we can log not only the resource usage with the timestamp, but also what was actually run at that time, then we can also create like a step optimization assistant or tool, which not only prints or visualizes the resource usage, but can say that, hey, at the beginning of the step, you are using GPUs, but then those are just sitting around and you're wasting resources. So maybe you should just split this step into two, because you do not need the GPUs for like 90% of your step. So that could be useful to save some related costs. And yeah, I have tons of related ideas as part of the open source Python package, and some related software as a service solution as well that I'm trying to figure out right now. So super happy to hear any feedback or recommendations. And that's it. I do not have any more slides, and it already went much longer than I thought. So sorry for that, but hopefully it was at least a bit useful.
This is super interesting, super useful. Definitely great work. Looking forward to all the future improvements. Yeah, and yeah, let's be in touch on how we could work together to get it to the next level.
Perfect. Thank you so much for the opportunity, and very cool questions and feedback as well. Really enjoy this. So thank you, guys.
Awesome. If no more questions, anyone? Yep. Thanks for taking the time, Gurgly. We'll be in touch.
Of course, sounds good. Looking forward to it. See you, folks.
Thanks, everyone. Bye.
Bye bye.
Thank you. Bye.